Example 2. Examples 2 and 3 are both an application of proportions. And what we have is a ratio problem. In this case, ratio of pigs to goats in the barnyard was 7 to 5. There were 91 pigs. How many goats were there? So when you deal with ratio problems and they give you specific numbers, this is the easiest way to do it using a nice little organizational chart like I have here. I want two columns, a ratio column, an actual number of things column, and I want two rows representing the, in this case, pigs and goats that we're dealing with, the barnyard animals. Ratio problems also extend into chemistry. If we're mixing several different chemicals to make up some compound, that's a ratio problem. So there's different applications of this. But the first sentence says the ratio of pigs to goats in the barnyard was 7 to 5. So pigs is first, 7 is first, goats is second, 5 is second. So in the ratio column, I'm going to put 7 with pigs and 5 with goats, because that's the ratio they give me of the two types of animals in this problem. The second statement tells us actual things. There were actually 91 pigs. How many goats were there? All right, so the exact number of pigs is 91. And I'm putting that in the pigs row because that's how many pigs there were. How many goats were there tells me I don't know that information. And then what I can do with that information in that chart that's been nice and organized, putting everything where it belongs. Both of these represent ratio numbers, 7 pigs, 5 goats. Both of these represent actual. There were actually 91 pigs. We don't know how many goats there were. Once you get everything set up in its right location, the fraction created by the first two equals the fraction created by the second two. You create a nice little proportion out of that. And I can cross multiply right now and go ahead and get what I'm going to get. So if I did that, I'm going to get 7x for this product equals, and then 5 times 91 is 455. Then I simply have to divide both sides by 7. Let's see, that'd be 65 goats. Alright, so we can find out exactly how many goats there were. Now, one other thing with proportions, let me show you this, and it didn't happen on the first problem, so I didn't even worry about it. This actually happens in this problem. Something to think about with proportions. And again, going back to my thought about multiplication. Okay, if it was this times this, I multiplied the tops, multiply the bottoms. If there's any reduction, we would look to see if any one of these numbers divided by any of these numbers, right? That's reductions with multiplication. With an equals, there's two places you can reduce on an equals. You can either reduce this fraction vertically, or you can reduce horizontally. Those are the two ways you're allowed to reduce in a proportion. If the numbers in the vertical fraction, where they're both number values, can reduce, you're allowed to reduce like a normal fraction. But also horizontally, you cannot reduce diagonally. This would not reduce with that. But if these reduce or those reduce, that's the legal step. And I'm going to keep 5 as it is and x as it is. 7 divided by 7 is 1, and 91 divided by 7 is 13. If I cross multiply now, I end up with 1x there, and 5 times 13 is 65. You get the same result. It's not a required step. With the use of calculators, it's not that big a deal if you get larger numbers because your calculator is doing all the heavy lifting for you. But just know that reduction is legal. It results in the same answer. It gets the numbers a little bit smaller and maybe has you relying less on your calculator, more on your brain. It's worth doing for that sense. But that's what I just wanted you to say. Yes, Amber?
Like, if it was, let's say you had the actual number was 49 or something, couldn't you just times across, like, and it was 7 and 49, and you knew 7 times 7 was 49, couldn't you take 7 times 5?
Yeah. And what Amber's question here involves what's called a scale factor. If we have a nice multiplier like 7, like she just said, and I can say that 7 times 7 makes 49, 5 times 7 is equal to 35, that is legal and will work, as long as you have a nice even number like that, then that'd be fine. And the same deal here, 7 times 13 is equal to 91. So 5 times 13 is equal to 65. That works too. We're using proportions rather than scale factor today, so I wasn't going to focus on that, but that is legal. They kind of fall into the same family, they're just done differently. So both techniques are fine, and either one can be used, whichever one you feel more comfortable with.